Sawyer. I'm going to talk about asynchronous programming a bit. Has anyone here worked in asynchronous? Who's the only me? Oh, that guy. Wait, it's just let me make sure this is, yeah. All right, cool. Who here hasn't worked with asynchronous programming? Has not. Wow, alright, so you can all go home basically. But I'm going to give the talk anyway. So the idea is that I'm going to start with the theory and then go into practice. Theory is more why and, well, I guess that's it, why. And the practice is how. So the theory is this. We think in non-blocking terms. And we act in non-blocking terms. But we program in blocking terms. And this is quite a dissonance in how we write our programs versus how we live our lives and how we think of things. And if you want an example, I'll be happy to give you one. Of course, you will not be able to see it well. Let's give it a shot here. I have some advanced features. No, it's not it. Wait. Not yet. There we go. Okay. I probably can't see it much better. There's an array of URLs, and there's a user agent, and for each URL in the array, we fetch it, and we print out the content. This is a simple example of synchronous programming. The question is, what is the problem here? So first of all, we wait on each URL. That means that for every URL that we want to fetch, we have to wait until the previous one finishes. If we have 3 URLs, the first one is 7 seconds. The second one is 3 seconds. The third one is 10 seconds. It will take us overall 20 seconds to finish it, even if the longest lasting HTTP request is 10 seconds. So it's a completely inefficient waste of time. It's pointless. It's senseless. It's a crime against humanity, or at least maybe just inefficient, right? Especially when we have a lot of things to do at the same time. So how do we really think? The way we think is that when there isn't anything that we need to work on at a specific given time, we just defer it to later, right? We just don't do it now until it needs our attention, and then we actually work on it.
So this is procrastination-based programming.
Procrastination-based programming, thank you. I think that's a technical term for it. So, alright, kind of like cooking. So let's take an example from cooking. Suppose we make dinner and we boil water. Do we actually wait for the water to finish boiling before we do other things? No, we defer the water to later. We start working on the salad instead. So basically the water gets deferred until it boils, and then we can actually do something with it. Then it needs our attention. Until then we can do something else. So we start cooking potatoes. Do we wait until the potatoes are done, or we do other things at the same time? This can take 30 minutes, 40 minutes, 50 minutes, an hour. I don't know what kind of potatoes you have. That's potatoes. So we don't wait for it. We start working on the sauce. So the potatoes here get deferred to later. And this is why I say that we think and we act in non-blocking. We don't let things block our way. We just defer them and continue on with something else. Of course, as with anything, there's more than one way to do it. You can do it using forks. You can do it using threads. Any hardcore Unix people will actually argue that these things are way too similar to count as different things. And you can do it using a single process in an event loop. And this is what this talk is about. So what are event loops? Event loops are basically a single thread. They're a single process running, and it's kind of like a big infinite loop where you have a hash of things that you want to run and when you need to run them. It makes heavy usage of code references. In order to dispatch things, we have to, in advance, put in a code reference to run at a scheduled time. So it makes heavy use of code references. There are no real race conditions because in an event loop it's just a single process, so you don't really have things clashing at the same time. And there's no locking, there's no semaphores. Much of the stuff you don't have to take care of. If you ever used threads, you hate this, and you should, because it sucks, and you don't have it with event loops. And some will argue that it can yield better speed because you don't have to do a lot of locking. I'm not going to get into that because I did read a lot of things that contradict each other, so I'm not that knowledgeable in either one to argue for that point, but some say it's true. One thing you have to count on is that you're going to have to think of everything that is locking and replace it with something that does not block. If you have an operation, I use the general term I/O, but it can mean network request, it can be file operation like reading, like opening the file or closing it, and it can be stuff like sleep. They're all blocking, and you're going to have to do something else because the loop always needs to run. So whatever it is you run that delays it, like a network operation or reading a really big file from disk or running sleep for 10 seconds, you're basically holding the event loop from running, and it can't continue on running. So you're going to have to replace it. And every event loop allows you, it gives you tools to replace it. Let's take a look at some event loops in Perl. There's Poe. Who here used Perl? Poe? Probably with Perl, I'm assuming. Reflex, which is, yeah, relax. Reflex is an implementation of Poe using Moose. Same author, really cool. There's async, lambda, Qt, GTK, TK, glib, Cocoa event loop, EV, FLTK, ERC. There's like a bunch of those. Almost all GUIs have their own event loop that they wrote because they think it's better. Because a GUI is an excellent example. A single process needs to show and to do multiple things at the same time. You have the window, you have a button, you have clickable events, you have typed events, so it's a lot of things running at the same time. And of course there's an event, which this talk is about. A lot of people ask me why do I do this using an event. So a few things about an event specifically. It's lightweight, it's very, very light. It's fast, it's not just fast, it's very fast. It has a very thin, slim interface compared to a lot of others. I have a lot of experience with Poe, and if you've never used it, it's really nice if you try it, but it's much more verbose when compared to any event, which is very, very tiny and thin in that regard. And of course it has good support for other event loops, and to be honest, pretty much all big event loops, that means async and Poe as well, they support a lot of other event loops as well. Which, what it means is that you get the syntax of one event loop, but it's actually running everything in a different while that someone else wrote. So I can use any event and say, use Poe's while loop, but give me the syntax for any event. So I can dispatch using any event, it will actually run it in a Poe loop, which is really nice because then I can do stuff like, I want to write GTK code, but I want to write it in my Poe program. So I can write using Poe and tell it to run it on GTK. And then I can use GTK widgets inside my Poe application, which is awesome. And of course there's a lot more.
One caveat to using any event though.
There is a caveat. The author is very opinionated. Let's leave it at that for now. Alright. So practice, how does cooking look with any event? The first thing I want to teach you is timers. We're going to take the cooking example, and we're going to use timers to showcase, we're going to use the cooking to showcase timers. So obviously you can't read this. This is fantastic. Let's try that nifty trick again. Does this help anyone? Yes. Let's see if I can do this. No? No? Alright, sorry. So, what goes on here, there's use any event, say water boiling, water equals any event timer. So I create a timer object. I give it two variables, two parameters actually. One is after, and that's 5 times 60, so it's 5 minutes. And CB, which is short for, nice, callback. And a subroutine, which is an anonymous code reference. It's a code reference, anonymous sub. And it just says the water boiled, I'm going to make the potatoes, and then creates another timer in 10 times 60, which is 10 minutes, and calls another code that prints out the potatoes are ready. this is the code that continues on. It prints out that the salad is being prepared. It creates a new timer after 6 minutes. It's going to call another code reference that's going to print that it finished the salad. Starts preparing the sauce, creates another timer, so we have 4. Meanwhile, 12 minutes, sauce is ready. So there's one timer for water. When it's done, there's one for potatoes. Then there's another timer for the salad. When it's done, it prepares the sauce. Water takes 5 minutes. Potatoes take 10 minutes after the water. It runs only when the timer is finished, right? It's the callback in 5 minutes. The salad takes 6 minutes, and the sauce takes 12 minutes after the salad is ready. What will be the order of things?
What are the salad? That's the same.
Hands. With your hand up. What was it?
It's like water, salad, potato sauce.
Right? Okay? So this is how it's going to run things. This is the printout. So there's the water, then it starts preparing the salad. So we've created the timer, threw in the background, continued on, created another timer, threw in the background. Now the timers are running in the background. The first one, when it's ready, it prints out that it's done, creates another one in the background. The second one, when it's ready, create another timer, threw in the background, and then they cascade downwards and finish. Let's take a look at something else. We saw timers, it's pretty basic. Let's take a look at condition variables. Condition variable is kind of like a prophecy. A condition variable is a variable that is false until it becomes true. And it's waiting to be fulfilled, like any prophecy. So, it starts as false, you hope to get it to true, and you need it in order to have other events finish. Let me give you an example. Suppose I set something to run in the background. When I write code, what happens when I reach the end of the program? Exits, right? It exits. I need somehow to delay the program to let things continue running in the background. What I need is actually the condition variable. So it's a variable that is set at the beginning, and then I can use this variable to say, you know what, wait here. Don't continue running the program. Wait here until it's true. It's false to begin with. So it's going to run everything in the background. Hopefully, something in the background is going to set it to true. When it sets it to true, then it's going to continue running. And I'm going to give you an example. You call receive to wait for stuff to finish. You call send to tell it that you finished doing stuff. And of course, without condition variables, we reach the end of the program. When we reach the end of the program closes. When the program closes, our code doesn't really get executed. When it doesn't get executed, we get executed instead. So, this is an example with a... this is so shitty. This is an example with a condition variable. What we have here is a count variable that's set to 1. CV variable is a scalar CV, and that's basically any event arrow cond var, which is short for condition variable. I create a condition variable. It's set to
False.
false. Excellent. Good listeners. So it's set to false. I create a new timer, and the timer has an interval of 1. We use after, before. After says, don't start it right away, start it in a certain amount of seconds. Interval says, start it every second, like run it every second or every 2 seconds or every 3.728 seconds, whatever. And you can combine them, of course. If you have an after and an interval, then run it in 20 seconds and every 3 seconds afterwards. So we have an after 1 for our timer, which basically means run it every second. And there's a callback here that's an anonymous subroutine that prints out the count, increments it, and compares it to 5. And when it compares to 5, if it's true, it will call CV send on the CV that we created earlier. After we created a timer in the background, we call CV receive, right at the bottom. And when we're done, we print out that we counted to 5. So what's going to happen is, we're going to create the CV. It has no side effects. We're going to create a timer in the background. It's going to run every single second. And right before the program closes, we actually tell the CV to wait, to receive. To wait to receive, that would be a better description. So the CV here actually waits, and the program stops. It doesn't actually stop from executing, it just stops from continuing to run the code afterwards. It just holds on this position. What's going to happen is that the timer is going to be able to get executed in the background. So it's going to have the first run, it's going to print out the count starts 1, so it's going to print count 1. It's going to increment it by 1 compared to 5. It's a postfix increment, so it's going to compare and then increment. Because it's not 5 yet, it's going to increment and that's it. It's going to wait another second, it's going to run again, then it's going to be 2. It's going to print it out, not going to do anything else. Keeps going 5 times until it reaches the point where the count is 5, and then it's going to call CV send. The receive picks up on that send and says, I got it. Alright, now I can continue running the program, right? So it continues off, it prints out we counted to 5, and it reaches the end. What happens then? Exit. It's done. So basically we allowed the timer to run 5 times in the background until it realized that it was done. It called send, receive picked that up, and we finished the program. Yeah.
What should we do that? So send actually means like go to.
Go to the receive and continue running.
Okay.
Exactly. The reason you need a condition variable is to allow things to run in the background. So it doesn't really stop the program, it just stops the reading of the program. It just holds off in that position, and whatever you ran in the background, it's still going to run. So if you ran a timer, you want the timer to finish, you can do one of two things. Either finish the program or undef the timer. As long as you're holding in that position using condition variable, the timer is still going to run. If it's an interval, if it doesn't have an interval, it's going to run once.
So what happens if you have, after that receive, if you have some code that takes some time? Will it still fire the timer and continue?
No, it's going to wait for that.
Yeah.
It's going to need the condition variable to actually run everything.
Think of it as a yield. So you're essentially context is switching back to the original, whatever's firing next.
The yield is more of the Poe convention for it. It's not necessarily something that every event loop uses in that
It can
terminology.
even be like a thread.
Think of it as
Threads
running
have yields.
the loop itself. So the timer actually throws a cell of logic into the loop. It says, when you run this at a certain time, and perhaps every certain time, run this. And then you have to tell it to start running. It's like running the wheel, I guess, spinning the wheel. So the converse spins the wheel, basically. Is that better? All right. A bigger example, which I'm probably gonna go through much quicker. This is basically saying that I cheated earlier when I ran the example with the dinner, because basically we created timers, but we didn't wait on anything. So created one timer, first timer, created the second timer, and then we did the program so it closed. What we actually needed was a condition variable that had to do a receive at the end, and probably the last timer should have called send on it, so it would finish. I'm going to skip it because you can't really read it. LWP example, if you remember, each one, where we have a for each, and then we just get, print, again, print. We're going to wait for the amount of time it will take for all of these URLs one by one, which could be a long time. When using any event, would actually use something like a condition variable. The problem with the condition variable, the way I showed it, is that the first instance that's going to call send is going to finish the program. So if I have 3 URLs, and I create a CV at the beginning, for each one, I run a request in the background using something like any event HTTP that gives me a method for HTTP. The first event that returns and calls CV send is going to finish the request, right? It's going to call the send, the receive is going to catch it, it's going to reach the end of the program, it's going to close. What happens if I want to have a condition variable that is compiled of multiple things? It's like a compound condition variable. I can use something like, any comment?
Semaphore or something.
Sorry?
A semaphore.
Like a semaphore. So what I can do is use something called begin and end using the condition variable. And the begin and end is kind of like a counter. You flip it on, you flip it off. So when you do begin, you flip it on by 1. You do a begin again, now it's 2. You do a begin again, now it's 3. Each time you do end, it negates it, decreases the counter, and then when it reaches 0, it's the equivalent of a send. So it basically means we're really done. The prophecy has been fulfilled. We can continue reading the program or close it when we reach the end. So what I do here is that I have a bunch of URLs. I create a condition variable. For each URL, the first thing I do is call CV begin, which says, hey, increment the counter. There's one request in the air. And then I do an HTTP get, give it a URL, give it a subroutine to run when it's done. And that subroutine is going to print the body, whatever, and it's going to call end, which means I'm done. This specific request is done. So if I have 3 URLs, each one is going to call begin. The counter is going to be 3. The first one with the returns decreases it, so it's now 2. Second one returns, now it's 1. Third one that returns, now it's 0. And then the receive is called. And then it continues reading it. There's nothing else, so it finishes. And this is how you run 3 requests at the same time. If the longest one takes 10 seconds, the overall will take 10 seconds, not more. So that's pretty nifty. So now that we passed all the technical information, the pop quiz time. Yes?
Yes.
Before? Alright, fine.
Yeah.
Yeah.
So it looks like a semaphore basically. You mentioned before that a condition variable is false by default, so can you still test the truthiness of it when basically it's like a counter that counts down to 0?
Sorry.
So it looks like a semaphore, right? It counts basically down to 0. And you
Yes.
said it's false and then it's true at the end, so is this one of those true but 0 things, or is this, can you rely on the truthiness of the condition variable when it's actually a semaphore that's counting down to 0?
I think that what it actually does when you use begin and end is I think the last end, like it knows that you started with begin, and the last end knows that it's fine. Like it doesn't actually check for true or false at that point. Like it understands the difference between begin and end versus send.
So what is it in numeric context?
I don't know how it's implemented internally. I have no idea.
Actually, if you send, even if you begin, the end, in the middle of that loop, if you actually send, it's like a shortcut. It always jumps.
Oh, yeah.
Direct.
Yeah.
So it works both ways.
Yeah.
That's always.
No, what I'm saying is that it differentiates end and send.
It's like end, so begin increments the counter, end decrements the counter. If end decrements the counter and 0, it then calls send.
Right, exactly. If you call send directly, it's like calling send
How
directly.
does the last send know it's the last one?
How does the last end know that it's the last end?
Symbol-
Programmer
symbol.
skills. The guy who wrote it this way.
Alright.
That
He
end,
keeps his
the
own
last
accounting,
end
so-
will work as
So
the
he keeps
last.
his own accounting scopes, or?
I'm assuming that it has an internal counter that when he reaches that,
It
the
maintains
end
it.
method checks that. So,
Yeah.
you should check the source, but I can tell you that it's probably going to be hard to read because the author is kind of crazy. Yes.
I am experienced in the field. Sorry. I work at booking.
He's not booking crazy. He's like,
He's just making it great.
yeah.
Challenge accepted.
No, it's. That's a good way of putting it because he's good crazy, but he's still crazy. So.
Can you avoid it somewhere in the middle, saying like, okay, now all went down the drain, and I just want to go to that receive?
Yeah, you can just call send. That's why Stas said.
So with receive and send, you can pass a value to send to get it out of receive. Can you do that when you're using begin and end as well?
No.
Okay,
As far as I know, you can't. With send and receive, I didn't say this, but with send and receive, you can actually throw arguments and receive them back at the receive juncture.
What happens if you have some situation like 3 tasks and you have to wait until those 3 tasks are done and then do a 4th task based on the results of your 3?
Sorry, what?
So suppose that you have 3 tasks.
Yeah.
And every task returns some result, and you want to, after all those are finished, you have to do a 4th task.
All right. So what if you want to do a task based on 3 consecutive tasks?
Yes.
Okay. Parallel task. I'm sorry. So yes, what I do is run CV. I call all the 3 tasks in parallel, do a receive, wait for them to return the end for each, and then I do the task right after.
So
That's
what you can do
perfect.
is you can accumulate the results into an array reference or something, and then reference them after you're finished processing them parallel twice.
You can also create 3 condition variables and assign one to each task, and then pass the result through when you call send, and then you assign them when you call receive on each one, and then you've got your results right there. And the loop runs independently of each individual condition variable. The timers and stuff aren't actually bound to a particular condition variable, so if any condition variable is running, the entire event loop is running.
Yeah, maybe I didn't understand your question.
Yeah, well, it's just.
If I have three things
an
running at the
example
same
of
time,
what-
then the fourth one that depends on them, I can just do the exact same thing and continue my code.
If you had like calculate values on, let's say you were doing 2 database fetches asynchronously, and you wanted to do
Yes.
something with the results of each. I
Oh,
think
okay.
that's what the idea is.
Yeah, well,
Is that the question?
The question were more like an example of, you know what it's called, the callback help?
The-
Callback help?
Callback
When
help.
you
Oh,
have,
yes.
asynchronous programming, you just
To
have
get
to-
away from that, you can use something like feature or promises, which are the same thing, just different
Oh, yeah.
implementations for it. For really, really advanced stuff, I use promises, which is really cool. But that's going to be a different programmer's talk. Probably where I'm going to do the Fed Packer lightning talk. Alright.
And then in the code that you use to load the URL, if you use LWT or the code you use to retrieve a database, to do a database query or whatever, they're all blocking. So when you call them, every time you call them, then once you're in those routines, they're going to be stuck there, right?
Unless you
It depends. It depends.
You're going to use, for every operation that is blocking, so that means also database calls, you're going to have to use a non-blocking equivalent of that.
Okay.
both
So
the-
where do you find all that? I mean, there's
So MetaCPAN will have it, yes. You can find it through MetaCPAN and install it through the CPAN mirrors. There's any event DBI, there's any event DBD, there's any event MySQL, there's, well, almost all event loops have a DBI interface because it's basically a socket connection. So they have a raw socket, a raw non-blocking socket interface. So then it's just writing a module that uses that to connect to the database. I think any event DBI specifically just forks like asynchronously. So it just creates a process, gives it a callback to run when it's done, and over there it does DBI stuff. But I think there's like a pure non-blocking MySQL using any event MySQL or something.
And
like that.
even MySQL might use the DB MySQL functionality to actually perform asynchronous calls.
Could be.
It does.
I think that's.
It does.
There you go. Okay, just go on CPAN via MetaCPAN, which is like the best implementation. Right. So let's do is that? Oh man. Nice. Okay. So let's do a pop quiz time. So the rules are this. There's a few examples. They have an error, maybe 2, maybe 13, no 12, and you get a spot the error. If you spot the error, you get a prize. Available prizes are handshakes, high fives, hugs, and kisses. Not necessarily for me, which is a good, I think a good deal. All right, let's start with worm 1. There's
You're always going to win.
You can't just keep
That
trying
makes
to just
sense.
read that.
Check it out.
There was a talk someone gave once, and he did a pop quiz as well. And he asked the first example, what was the problem? I raised my hand and I shouted, "It's not indented!" But he didn't accept it as an answer. So, alright, I'm going to read it out, so bear with me. Use any event, and use any event HTTP. Any event HTTP gives you HTTP get, HTTP post, so those are interface to asynchronous HTTP calls. So there's HTTP post coming from any event HTTP. You give it a URL as a variable, you give it the body as a variable, and you give it a code reference. The code reference just says, say successfully made an API call to do something cool, and over here it says wait for all events to finish, so there's an any event convar receive. Just any event, arrow convar, arrow receive. What is the error? Hands, because when you talk without hands, I have no idea where to concentrate and focus and hear what you're saying. Yes,
You never sent? And,
you never send, that's true.
so
So suppose I have CV send here, and even convar send.
Give us a kiss.
Alright, round 2. So here, use any event. I have a timer. So my timer is any event arrow timer. I give it an interval, 5 every 5 seconds. And I have a CB here. The callback is a code reference that says sleep 1 and print something.
Your timer object gets collected right after you create it.
I didn't hear.
Your hand. Alright, fine.
Sorry.
So what would you? How would you change that?
I would say my timer, semicolon, and then undef timer in the CD. I've used any event a lot.
Yeah,
Or you can keep it a global reference.
but you're missing something.
blocking the entire
All right,
variable.
another problem. Nice. What about a condition variable?
Yeah,
To keep
so
things
it-
running?
It's not gonna finish the program.
Right, it's gonna get
Off
to the end and
time.
just close off. So we have it here. It's nice.
Sorry.
It's gonna be like a sweaty hug or something disgusting. Like hard, nice, hard, disgusting. Catch tomorrow morning. All right, round 3, doing well so far. So there's use any event. I have a condition variable here this time. All right, okay, and I have 2 players. So the first player is an any event timer. After 3.7 seconds, that means run it in 3.7 seconds. There's a callback here that just prints player 1 joins the game, and it does a CV send. Then there's player 2, an event timer. After 7.2 seconds, arbitrary time, print player 2 join the game, and there's another CV send, and here there's a CV receive. What is the problem? And
It's never gonna run the player 2. So after player, the player 2 would only run after player 1, but player 1 ends by ending the code.
excellent, claim your prize. The problem is that player 1 is going to call CV send, it's going to reach the receive, and the program closes. How would you fix this?
You can just remove the send from player 1.
See, he knows how it works. Yeah, that would work. Alright, now I shouldn't ask how you would fix it. How would someone else fix it?
Use Perl.
Have another condition variables? No. Use Perl?
You
Incorrect.
can increase the counter of your variable.
What was that?
You can do a begin.
I'm gonna start pointing at people with this.
You can increase the counter.
Someone got mad at
variable,
Yahtzee.
with the other method I forgot the name.
So
And
yeah, there's
increase
someone.
at the end of each one. So it will only end after the second
Yes. Does anyone know the name for it?
begin.
What was that, sir?
Beginning?
Excellent. Begin and end. Nice. Good. Round 4. You're doing well. There are 38 rounds. We're getting there. So use any event. Use HTTP Tiny. Who here knows HTTP Tiny? Thank you, Nick. All right. So there's a CV here, convar. I use begin here. I use it twice. So there's a begin for 1 to 2. So it runs begin twice, increments it. Then there's player 1 timer. After 3.7 seconds, there's player 2 after 7.2 seconds. The first one says player 1 joined the game, alerting server, and it's running a call using HTTP new get to whatever. And if the result is success, does nothing. If the result is not success, it dies. And then it calls end, and the second player just prints how they joined the game and does end. There's a receive at the end there. I'm sorry, you already answered. Anyone else?
You have a blocking call using HTTP Tiny.
Exactly.
I should start with anyone else who isn't Nick. So yes, the problem here is that HTTP Tiny is blocking. So this HTTP call, if it takes a long time, say server's down, you're waiting for TCP timeout, it will actually block the entire loop. So the timing, at least, will be off completely. But you're basically blocking. It's like asleep in the middle.
Sorry, another thing that
Another thing?
is the time.
Really?
The time gonna work anyway? Because if you send the end, it's not gonna end up. At the end, okay. The end's for the beginning.
I
And
think you got it right.
okay.
Can I ask you something?
Yes, you
I
can.
have more than that.
There are 2 ends. The player 2 also does an end.
Okay.
But
Okay.
good. Sorry. Yes, readability is crucial. Yes.
You said the timing will be off. Does this mean that for as long as you have a blocking part, it won't time the timing in its event loop?
Yes, the timer will be off, but also any other background event will not be running because the event loop is not running. It's actually stuck. So if you have another timer running in the background now, it's not running. And if you have, suppose you don't have a timer, suppose you have like an HTTP server in the background. It's not running. It's not accepting any requests because it's blocking. The event loop cannot really hold.
So the goal of doing asynchronous programming, especially in Perl, regardless of which event loop you choose, is to have basically break your program up into very tiny chunks, very tiny time slices, where it's like the subroutine does its one thing and exits very quickly. Because what you're essentially doing is cooperative multitasking. You are basically playing MS-DOS with Perl.
For any
I love the way you describe things.
Nick, that's true for any event loop, not just any for
Correct.
We're running MS-DOS with stuff that aren't MS-DOS.
What happens?
Probably not as
badly.
as beautiful as
What
it
happens
is.
when you reach the limit, when your small code or small pieces of code that run will not fit into the time slice for the event loop?
That happens.
Well,
Yeah, it operates slower. So basically anything that's timer based, those will execute as soon as the next time slice occurs. It'll be late. It will not happen on the boundary.
my answer would have been that it depends on the computational intensity of what you're doing. So
I mean, if you just have too much code that runs.
it's not just too much code. The amount of code is not the problem. The
If I have 16
computational
code
intensity is. The computational intensity of it is. It can be 3 lines and be very, very intensive and take a lot of time.
Yeah,
It can be
that was the best
30 lines
like-
and it would be really fast. So it's not about the size of it, more of how intense it is, how difficult it is to run,
Yeah.
how long it takes, and how much it might delay the event loop. I can tell you that I wrote some really heavy stuff with it, and I've yet to encounter that as a problem, but I have no idea what you're doing. So I can't answer for all situations. What Nick said is totally true. I haven't encountered it myself. So let's say that it's more than feasible to actually write heavy production stuff with it. Yes,
Isn't it more,
the person with the shirt.
they're camels.
Oh.
I don't even do any curl. If I understood correctly, because it sounded like you're talking about green threads, sort of, the limit with threads was your CPU, but your limit with your green threads or your events isn't it memory? Isn't that your biggest limiter with your green threads, your greenlets? It's kind of what these sound like. They sound like green threads.
Wow. I don't think this counts as green threads. My short answer is I don't think this counts as green threads.
How is it?
As far as I know.
Basically, it's
That's my short
it's
answer.
implemented as a queue of subroutines. Whereas no.
It's like a cache of events, basically. This is bound to a single CPU all the time.
Now, that's not to say that you can't introduce sub-processes that are also running an event loop and communicating back and forth. That's a very popular thing.
Yes, of course. You can pre-fork this. You can pre-fork an event loop and have multiple. So a high executing server would actually pre-fork event loops. So stuff you can do with any event. I'm reaching the end. I'm sorry. So stuff you can do with any event. XKCD. Who here doesn't know XKCD? Right, great. So it's a wonderful comic strip that you have to start reading. It's written by someone from, I think he left NASA to continue working on the comic full time. So this is how cool this person is. A lot of geek stuff. And apparently it has like a full API interface. And CPAN didn't really have an API for it. So I wrote one. It took about 20 minutes. There's use www.xkcd, lowercase on purpose, create a new object, and then you can call fetch, and you can give it a code reference that will receive the image and the comic in the parameters, and then you have everything. It's totally asynchronous. The fun part with this thing is that it's also synchronous. It does both, which was fun to write. Alright, other stuff you can do with any event. PSGI Plaque server. So Twiggy is a PSGI server written in any event, and one really cool thing that I like to do is when I have really heavy servers, really heavy daemons that run for a really long time, I hate to check the logs for everything to know the current status. So what I do is use introspection by running a small HTTP server in the same process, in the same event loop. And this basically does use Twiggy server, create a code reference for the app, create a new server, register the service using the app, and then that's it. It's running in the background. And then I have a full API to the application, so I can actually just cURL localhost whatever port /dump, and I will just dump all the variables live, for example. So I can have an entire interface to my daemon, and it's very, very useful for introspection. One more thing is asynchronous AWS EC2 interface, so it's the Amazon Web Services Cloud Computing, and so there's an event EC2 Tiny that uses Mark Allen's net EC2 Tiny, and there's basically a new object called send. Give it a region name, give it an action like describe regions, which basically gives you all of the instances that you have in a specific region in Amazon, and code to run if it's successful, code to run if it fails. That's it, it's asynchronous. One more thing is a monitoring framework. I worked at a big web portal in Israel, and I left and worked at a different company. A friend of mine went over there, and he had to write something that I wrote in the second company also. We both had to write a service that checks servers. So I had to use ping and HTTP, he had to use SNMP, but we basically had the same loops to monitor these servers. So we decided to join forces, and we came up with something called Juno, and basically you give it hosts, intervals, what kind of checks to run, like HTTP or SNMP or ping. It has a lot of different things, and basically it will run the stuff for you, and you can give it callbacks to run if it's successful, if it failed. If you don't want it to decide for you if it failed or if it's successful, you can give it an on-result callback, and basically you have a checker running in the background all the time. One more thing, a real-time network resolution, network path resolution. We had a server, not in Booking, a different company. We had a server, and it had a few network interfaces, and it needed to get to, say, 10 websites. The problem was that each time the network interface was so shitty that it went through a different continent each time. And the problem was that sometimes the website was down from this network path and sometimes from this one. So it was always available from one of them, but it would change. And it wouldn't be the exact same thing for all websites. So one website would work through this interface while another one wouldn't. So you had to use the other one. So what we wrote is a simple program, and when I say we, I mean, well, me. You can't see the code, but basically it's a TCP server that holds for requests, and then just a callback that checks if it has information about that website for that network interface, and just returns a result of all the best one. There's a small script here that basically, the small piece of code here that basically creates a timer, pushes into an array of timers, and each timer basically checks each website through each network interface. That was a very, very simple thing to write. This is the entire code. Like all of this is the entire application code. It took about, I think, an hour. That was it. It was done. It works till now, even now. One thing that I was talking about for introspection, one of the nice things I had here was that if you ran this in verbose mode, it would basically add another timer that every 5 seconds would just dump the data. So when we wanted to see what it sees from the different network interfaces to the different websites, we just ran it locally with -v, and suddenly you get every 5 seconds a dump of every website result through every network interface. Very useful. It took and added, it's a single line. So, beautiful. API interfaces to services, so any event React, any event SNMP, any event XMLRPC, DNS, Twitter, Graphite. So a bunch of services that you can work with asynchronously and write and run calls to them while you keep running your stuff. And last, this is the last thing I'm going to show. Find matching special actors in TV series. This is one of the things that I really enjoy writing, even though it's not used by anyone ever, anywhere. Do you ever get this thing where you watch a TV series? Who here watches TV series? Any? At all? Everyone? Wonderful. So do you ever get this thing where you watch an episode and you see an actor and then you watch a different TV series and you see the same actor? Do you ever get that? And then you see another one, you see the same person over and over again, and then you realize, I saw him before. And then he vanishes, disappears, and then a week later you start seeing your TV series again, and then there's someone else, and you see her here and here and here, you know, I saw her before. And it drives me nuts because when I see them, I know they're the killer. I know there's something with that actor or actress. So I call them cross actors. And I don't know how many of you act the way I do, but when I see them, the first thing I do is stop, I pause, I go online, I go to IMDb, I search for the series that I like, I search for the episode, I find the actor, I go through their entire history and see what else have they done that I saw. And this might mean that I need help. Yes. But therapy is expensive. And what's cheaper is to write an application that basically does all of that for me.
Right.
That's much better.
Yeah. Yeah, it's much cheaper, it takes much less time, and I feel way better. So I won't write it because that would be a lot of requests to IMDb, and that's probably going to hammer their servers for a bit, and that's kind of abuse. So I wouldn't write such a thing. However, if I had written such a thing, this would be the code. So there's it's good that you can't see it. So there's a bunch. So there's a bunch of titles here that I took from IMDb, if I had written it. And there's some regex here that you shouldn't ever use, and I'm happy I didn't write it because you shouldn't ever use regexes for HTML. It will always break like a minute later.
It will call salvo.
Sorry?
It will call salvo.
The
It will?
center cannot hold.
I can't hear you. Oh, yeah. So I have a CV for each title. I create a regex. I do a begin for each title. I run HTTP get to the URL. Here I analyze the result I got. So basically I'm fetching for each title I'm fetching the amount of seasons that this title has. Then for each title I go through each season that it has and I fetch the number, all the episode. Let's see if I can, yes, I fetch every episode, and then for every title and every season and every episode I fetch the entire cast, because the cast doesn't work by series or by season, it goes by episode. So I have to go all the way in, and then I fetch each actor, and populate some stuff, cross-reference, and let's look at some data. So first of all, I had 6 TV series this time, 42 total season throughout these 6 TV series. Overall, a total of 1,510 episodes, 6,484 total actors, 7,493 roles that they played, 380,520 total requests. Now, let's say a request takes 2 seconds. Suppose a website, you go to IMDb, you pick something, it takes 1, 2, the page loaded. This is pretty fast. Let's say it's doable, as long as it's not your website, right?
You did run it on IMDb.
So, sorry?
You did run it on IMDb.
No. Not that you can prove.
7493, it's not a
Hypothetical numbers.
Sorry, what?
These are really purely hypothetical numbers.
Totally hypothetical. Including the serialized dump files that I have. I did a lot of hypothetical stuff there. So, say each request takes 2 seconds, which is fine, right? We can all live with 2 seconds. It's 761,040 seconds overall, 12,684 minutes, which is 211 hours if I wait for each URL until I hit the next one. That's 8.8 days. That's a lot of therapy. The time it took me to run all of this, including analysis with any event, if I had run it, and this is by being actually nice, where I actually fetch all of the season, every single season at the same time, instead of all of the seasons at the same time. So this was even kinder. 6 minutes. That's a good usage for asynchronous code, right? It's a good example of why it's useful. the amount of matches that it found is 1,095. And a few of these matching, Patrick McGill played in Seaside, Las Vegas, in Dexter. Robert Esser played in Seaside, Las Vegas, which is the only one that exists as far as I know, as far as I care, and in Castle. Andre Alexin played in the closer and in the medalist, and you can notice, this is interesting, he went from an uncredited performance to a character with a name. This was an upgrade. Then again, he was California State Governor beforehand, so that's a pay cut, right? Then again, California, so a lot of consideration. Becky O'Donoghue played in Seaside, medalist in Psych, and you can notice this is another fetish that I have, and I should call it fetish because it is, that she actually makes the jump between drama-based and comedy-based. I thought about graphing this out. Perhaps this indicates a problem with her career. She made the gap, no one else did. This is by far the most accomplished cross-actor, Mark Pellegrino. Who recognizes him? Alright, good. No one. So he played 1, 2, 3, 4, 5. This is actually a 6th character in the same episode. And that's 5 TV series out of 6. He didn't make the jump to comedy. Why? What does this mean? I don't have time for it, but I will find out. So there's a whole lot of other stuff that are awesome that you can do with any event or any asynchronous programming, which I will not show now. That's about it. Thank you.